welcome back. In this video, we are going to be covering topic 1.8, which is the squeeze theorem, specifically for AP Calculus. So let's take a look at the first question here. It says, let f be a function of x. The value of the limit as x approaches a of f of x can be found using the squeeze theorem with the functions g and h. Which of the following could be graphs of f, g, and h? Okay, so what am I looking for? Basically, what I'm looking for is I'm looking for f of x to be squeezed in between g and h. So just looking through these quickly, immediately I'm going to eliminate answer choice A. Here, f is just not being squeezed, right? It's almost kind of like crossing through those, and that's just not what we're looking for. So we're going to eliminate that. Answer choice B looks promising. However, F is really only squeezed on this side. So you notice here it's in between G and H, but over here it's actually not, right? It ends up coming up here. So we're going to eliminate B too because it's not squeezed. C, same thing here. We have too much of a buffer here, right? We need these values. We need it to literally be the same thing and squeeze it in there. So C is too wide. We're going to say no. And then moving on to answer choice D, this one is looking good. So what am I looking for? Again, F is in the middle of G and H, and it's being squeezed at this point, right? You can see how it's really just squeezed in there. Sorry, I keep using the word squeeze, but I'm just emphasizing it for the name of the theorem. Okay, so in this case, that would be answer choice D. All right, moving on. So now we are going to see how the squeeze theorem is applied more algebraically. Okay, so this question says, let g and h be the functions defined by g of x equals negative x squared minus 2x plus 3, and h of x equals 1/2 x squared plus x plus 13 over 2. If f is a function that satisfies g is less than or equal to f is less than or equal to h for all x, what is the limit as x approaches -1 of f of x? So on your exam, you're not directly going to be told that this is a squeeze theorem problem. So I do want to note what you're looking for to be able to identify it as such. So basically it's this here that's tipping me off that this is a squeeze theorem problem. And also, of course, it has to do with limits, right? So if I see limits and I see this, I'm immediately thinking squeeze theorem. Okay, so now in order to actually use the squeeze theorem, what we have to do is we have to take the limit as x approaches -1 of g, and then we have to take the limit as x approaches -1 of h. So let's go ahead and do that using direct substitution. Apologies, I'm going to be a little sloppy with my notation just because I don't have unlimited space. So I'm going to go ahead and plug in -1 here into g. So I'm going to get -1 squared minus 2 times -1 plus 3. All right, so this is -1 squared is 1, so that's -1 plus 2 plus 3, so that's going to give me 4. Now let's do the same thing for h, and this is the limit as x approaches -1. Direct substitution, I'm going to get 1/2 times -1 squared plus -1 plus 13 over 2. -1 squared is 1, so 1/2 plus, I'm sorry, that should be a -1, and I'm going to write that as 2 over 2 to get a common denominator, plus 13 over 2. So now 1/2 minus 2 over 2 gives me -1 over 2, plus 13 over 2 gives me 12 over 2, which is 6. So in this case, this is kind of like the example from above. Actually, this is really good. Let me relate it back. So in this question, we eliminated answer choice C because the numbers were too far apart, which is exactly what we're seeing here. We're not seeing the limit of G the same as the limit of H. So in this case, this is the limit cannot be determined from the given information. We don't have, if they equaled the same number, we could conclude the limit of f was that number. But since we don't, the limit cannot be determined. All right, moving on. So this question states, let g and h be the functions defined by g of x equals sine of pi over 2 times x plus 2 plus 3, and h of x equals -1 over 4 x cubed minus 3 over 2 x squared minus 9 over 4 x plus 3. If f is a function that satisfies g is less than f is less than h, again, this here is tipping me off that this is a squeeze theorem problem. For -2 is less than x is less than 0, what is the limit of f of x as x approaches -1? So again, in this case, I'm going to apply the squeeze theorem by taking the limit of g and the limit of h. So again, I apologize for my sloppy notation, but this is the limit as x approaches -1 of g, and I'm going to go ahead and use direct substitution. So that is going to give me the sine of pi over 2 times -1 plus 2. I'm going to go ahead and just do that now. That gives me 1. Okay, plus 3. And then let me just go ahead and simplify this down a little bit further. So this is the same as sine of pi over 2 plus 3. The sine of pi over 2, if you remember, is just 1. So 1 plus 3 is 4. So the limit as x approaches -1 of g is equal to 4. And just a quick little side note how I have that memorized. I just have the basic sine wave or curve for one period memorized visually. And so I know at pi over 2 it equals 1, just in case you need to refresh or remember that. Okay, now let's do the limit of h of x as x approaches -1. So again, I'm going to use direct substitution here. So -1/4 times -1 cubed minus 3 over 2 times -1 squared minus 9 over 4 times -1 plus 3. Okay, so this is going to give me a positive 1/4. This is going to give me a -3 over 2. This is going to give me a plus 9 over 4, and then a plus 3, but I'm going to get a common denominator, so I'm going to rewrite that as 12 over 4. Last thing I need to do is get a common denominator here. So this would give me 6 over 4. So 9 over 4, 12 over 4. Okay, I could have, well, never mind. Let's just keep going. Okay, so I'm going to add first. So my 1/4 plus 9 over 4 plus 12 over 4, that's 10 plus 12, which is 22 over 4 minus 6 over 4, which is going to give me 16 over 4, which is the same as 4. So now we see a case where we have successfully applied the squeeze theorem to find the limit of f of x, which in this case would be answer choice C, number 4. Okay, this question says, let g and h be the functions defined by g of x equals -2x squared plus 4x plus 1, and h of x equals 1/2 x squared minus x plus 11 over 2. If f is a function that satisfies g of x is less than or equal to f of x is less than or equal to h of x, for all x, what is the limit of f of x as x approaches 1? Again, this notation is tipping me off that this is a squeeze theorem problem, so I'm going to go ahead and use direct substitution. So let's start with the limit of g as x approaches 1. Using direct substitution, I'm going to get -2 times 1 squared plus 4 times 1 plus 1, which is going to equal -2 plus 4 plus 1, which is the same as 3. Now let's go ahead and do the same thing for h. So using direct substitution, I'm going to get 1/2 times 1 squared minus 1 plus 11 over 2. Okay, so 1 squared is just 1. So this is 1/2 minus 2 over 2, getting a common denominator, plus 11 over 2. So this is going to give me 10 over 2, which is 5. So you'll see here we have this second case, or the second problem that we've done today, where these numbers do not match, and therefore the limit cannot be determined. So again, as a quick little refresher, in order to be able to apply the squeeze theorem, these limits have to match. So since they don't, the limit cannot be determined from the information given. All right, thanks so much for watching, and keep an eye out. I'm going to be doing a second squeeze theorem video in which we cover a different type of problem. All right, see you then.